Dear students, I am Ramesh, chemistry faculty from Vidya Mandir Metric Higher Secondary School, Uttangarai. Now, we are discuss integrated rate equation. Now, we are taking the reactant A, it will be gives the product. It will be gives at the product. Rate is nothing but change in concentration of the reactant with respect to time. So, here change in concentration of the reactant A with respect to time is nothing but rate. Now, the negative sign indicates decrease in the concentration of A. And according to rate law, we are taking rate law. So, according to rate law, we are taking that rate. So, rate is directly proportional to concentration of the reactant. So, rate law explain rate of the reaction is directly proportional to concentration of the reactant. Now, we may equalize it is rate is equal to K is a constant and concentration of A. Now, both are rate. So, we may take that here it is rate is equal to minus D into concentration of A with respect to time, and it is equal to K into concentration of A. So, it is the rate. And the differential equation which explains the rate of the reaction at any instant. So, the rate of the reaction at any instant is explained by this differential equation. Now, here it does not explain the first one here after time t how much reactant is completed. So, after time t how much reactant is present. How much reactant is present is not explained by this differential equation. So, here how much time is required to complete the reaction. So, these two are not explained by this differential equation. So that we are taking integrated rate equation. And so, this differential equation is converted into integrated equation because this does not explain after time t how much reactant is present and how much time is required to complete the reaction. Now, we are taking that is rate constant for first order reaction. So, we are taking A, it will be gives at the product. A gives at product. Now, we are taking that is here rate is directly proportional to concentration of A power 1. So, according to rate law, rate of the reaction is directly proportional to concentration of A power 1. And here, the 1 is nothing but order of the reaction. Now, explain what is it first order reaction. The concentration of A is raised to the power of 1, which is known as first order reaction. Now, integrated rate law for the first order reaction. Now, that is A, it will be gives at the product. A gives at product. Now, we are taking that is rate. Rate is nothing but decrease in the concentration of the reactant with respect to time. And according to rate law, we are taking rate law, we may find out that is the rate. So rate, which is nothing but are directly proportional to concentration of A power 1, and it is the first order reaction. So here rate of the reaction depends concentration of A. It is raised to the power of 1, which is known as first order reaction. Now we may take that we are equalize this. So rate is equal to K into concentration of A. Now both are rate. So we are take rate which is equal to minus D into concentration of A with respect to time, which is equal to K into concentration of A. Now it is the differential equation. Is rate is equal to, that is minus D into concentration of A, and divided by concentration of A, which is equal to K into dt. Now we may integrate both sides. So here integration with the limit of A naught into concentration of A, concentration of A naught to A, and here it is D of concentration of A with concentration of A, which is equal to K into, here it is 0 to T, and here it is dt. Now the integration and the differentiate are cancelled out. So we are taking that is the natural logarithm, that is minus ln concentration of A and power concentration of A and concentration of A naught. Concentration of A and concentration of A naught, which is equal to concentration and T minus 0. Now we are taking that here, that is minus log, that is natural logarithm of concentration of A minus into minus of ln A naught, and which is equal to K into T. Now here what is it? Minus into minus, it is plus. So minus ln concentration of A plus ln concentration of A naught, which is equal to K into T. Now it is arranged, that is ln concentration of A naught minus ln concentration of A, which is equal to K into T. Now we may take that here it is ln concentration of A naught by concentration of A, which is equal to K into T. Ln A naught by A, and it is a natural logarithm. Now we are taking the natural logarithm ln, which is equal to 2.303 log base 10. Ln, which is equal to 2.303 log base 10. So instead of here ln, we are taking that it is 2.303 log base 10 concentration of A naught divided by concentration of A, which is equal to K into T. Now we may take the rate constant K, which is equal to 2.303 by T log concentration of A naught by concentration of A. Then it is the first order rate constant. First order rate constant K, which is equal to 2.303 by T log A naught by A, and here A naught is nothing but initial concentration and A is nothing but concentration after time T. Now we may take that the examples of first order reaction. Examples of first order reaction. Now the first example, decomposition of nitrogen pentoxide. You know that nitrogen pentoxide N2O5, and decomposition gives that 2NO2 and that of O2. And the second example, we are take decomposition of hydrogen peroxide. So here hydrogen peroxide on decomposition form that is water and of O2. And the third one here, that is sulfuryl chloride on decomposition on gaseous phase. So here SO2Cl2 gas, SO2Cl2 gas, which is known as sulfuryl chloride. Now, the sulfuryl chloride decomposition gives that is SO2 and that Cl2. And the fourth one, it is isomerization of cyclopropane. And you know that it is cyclopropane. It is on isomerization. Isomerization. So, isomerization of cyclopropane gives that is propene, CH double bond CH. And these are the reaction follows first order kinetics. Now, we are taking that the graphical representation of a first order reaction. You know that is ln A naught minus ln A, which is equal to K into T. Now, we may find out that is a ln A. Ln A is nothing but, so here it is half life period. What do you mean by half life period? Half life period is defined as, it is the time required for the reactant concentration to reach one half of its initial concentration, which is known as half-life period. Now, we may find out the half-life period of a first order reaction. And you know that here K, which is equal to 2.303 by T log concentration of A naught, that is initial concentration, and that is concentration of A. And it is first order rate constant. Now, in this equation, when T is equal to Tf, that is half-life period. Now, here concentration of A is taken as, that is initial concentration by 2. So, the time required to disintegrate one half of its initial concentration is nothing but its half-life period. So, we may substitute it here K, which is equal to 2.303 by T of log A naught, that is concentration of A naught, divided by, instead of A, we are taking, that is A naught by 2. So, A naught cancel. Then we are taking that, it is log 2. So, it is 2.303 by T of, that is log 2. And you know that the log 2 value, it is 0.3010. So, here log 2 is nothing but 0.3010. So, we may substitute 2.303 by T of into 0.3010. Then we are getting here, it is 0.6932 by T of. So, here it is nothing but K value. So, K, which is equal to 0.6932 by T of. Now, we are taking that here T of, which is equal to 0.6932 by K. 6932 by K. And in this equation, there is no initial concentration. So that here Tf of first order reaction, Tf of a first order reaction is independent of initial concentration. Initial concentration. So here Tf of first order reaction is independent of initial concentration. Now, we are taking integrated rate law for zero order reaction. Now, here it is A gives it the product. A gives product. Now, we are taking that is rate. So, here rate is nothing but decrease in concentration of A with respect to time. And according to rate law, we are taking that is rate law. According to rate law, we are taking that rate is directly proportional to concentration of the reactant, that is A power 0. And here we may define, that is a zero order reaction. What is that, a zero order reaction? Rate of the reaction is independent of concentration of the reactant is known as zero order reaction. So here rate is equal to K into concentration of A power 0. Anything power 0 is 1. So rate is equal to K. So for zero order reaction, that is rate is equal to K. And rate is equal to, that is minus D into concentration of A with respect to time, which is equal to, that is K. So we are taking that the integration of both sides, here concentration of A naught and here concentration of A, and here it is D into concentration of A, which is equal to, that is integration 0 to time t, and here K into T. Now we may take that here concentration of A, and it is negative sign, and it is concentration of A and concentration of A naught, which is equal to K into T minus 0. K into T minus 0. Now we are taking here, that is minus concentration of A minus into minus of concentration of A naught, which is equal to K into T. So what is that? Here minus concentration of A plus concentration of A naught, which is equal to K into T. K into T. So here that is concentration of A naught minus concentration of A, which is equal to K into T. So here K, which is equal to concentration of A naught minus concentration of A by T. So it is the rate constant for zero order reaction. Concentration of A naught minus concentration of A, which is equal to K into T. Now concentration of A is equal to, that is concentration of A naught minus K into T. So here in the form Y equal to C plus mx. Now we may take that in the y-axis we are taking here concentration of A, and in the x-axis we are taking, that is time. Now what will happen? Here we are getting that m is nothing but the slope value. We are getting the negative slope. So here it is a slope, and here it is the slope value is equal to, that is minus k, and the intercept value is nothing but concentration of A naught. So it is graphical representation. An example of this zero order reaction. So here we are taking example of zero order reaction. And all photochemical reactions are zero order reaction. So here H2 plus Cl2 in presence of a photon gives that is 2HCl. It follows zero order reaction. Iodination of acetone. So here CH3, CO, CH3 on iodination. Iodination in presence of H plus and form ICH2, CO, CH3. And with that HI. Now here the rate does not depend, that is iodine. So here rate is equal to K into concentration of acetone and concentration of H plus. So it does not depend I2 concentration. And here the third equation, decomposition of N2O, and it will be gives that is N2 plus of O2. It is also follows zero order reaction. Now we are taking the half-life period of a zero order reaction. Now we may take the zero order rate constant K, which is equal to concentration of A naught minus concentration of A by that T. It is a zero order rate constant. Now here we are taking T, which is equal to T off. It is half-life period, and here concentration of A is taken, that is initial concentration by 2. So you know that half-life period, the time required to disintegrate one half of its initial concentration is nothing but half-life period. So we may substitute it here K, which is equal to, what is that? It is A naught minus here A, instead of A we are taking A naught by 2 divided by, that is T, and it is 1A and half A, so we are taking, that is A naught by, that is 2 T off. So here it is T off. So here T off, which is equal to concentration of A naught divided by 2K. So it is the half-life period of a zero order reaction. Now here T off is directly proportional to initial concentration. So here for a zero order reaction, here the T off is directly proportional to, it is initial concentration. If it is a first order, it is independent of initial concentration. We are take pseudo order reaction. Then what do you mean by pseudo order? Why we are taking this pseudo order? Now we are take here the study of second order or higher order reaction are difficult. Higher order reactions are difficult. So the study of higher order or second order reactions are difficult. Why? Suppose we are taking the example, then here we are taking a second order reaction. And in a second order reaction, that is rate is directly proportional to concentration of A and concentration of B. So two different reactant is taken. And here it is the power 1 and it is the power 1, so that here m equal to 1 plus 1, so that order is 2. The simultaneous measurement of change in concentration of both the reactant is very difficult. So this higher order reaction is converted into lower order reaction. So here this higher order reaction is converted into lower order reaction. So here how we may take the higher order reaction is converted into lower order, and by taking one of the reactant concentration will be taken as larger excess. So here by taking one of the reactant concentration, is taking us larger excess. So if we are taking, if the concentration of B is taken as larger excess, then the rate of the reaction is independent of B. So the higher order reaction is converted into lower order. This type of reaction, which is known as pseudo order reaction. So this type of reaction is called as, pseudo order reaction. So what do you mean by pseudo order reaction? The higher order reaction is converted into lower order by taking one of the reactant concentration is larger excess. Now we may take the example of a pseudo order, and it is hydrolysis of ester. Hydrolysis of ester in acid medium. Then this is an example of a pseudo order reaction. Now we are take the hydrolysis of ester. It is CH3 COO CH3. This is a ester. On hydrolysis, it will be gives acid and alcohol. So here it is a acid and alcohol. CH3OH. Acid and alcohol. Now here we may take that rate is directly proportional to this ester CH3 COO CH3 and concentration of water. Now it is power 1 and 1. Actually it is the second order reaction. Now here the concentration of water is taken as large excess. Large excess. You know that? So the solvent is water. So the solvent is always taken in that larger excess. So what will happen? There is no change in the concentration of that water, or it is negligible amount. Change in concentration of water is taken as constant. It is, and so we are taking that is K into concentration of water is nothing but K dash. So what will happen here? That is rate is equal to K into concentration of CH3, COO and CH3, and here concentration of water. K into concentration of water is nothing but K dash. So rate is nothing but K dash into that is CH3 COO CH3. Now K dash is nothing but pseudo order rate constant. So it is pseudo order rate constant. So it is the pseudo order reaction. Now we may prove that T 99.9% completion, which is equal to 10 T50. Now you know that is first order rate constant K, which is equal to 2.303 by T log concentration of A naught by concentration of A, and it is initial concentration and it is after time T. Now we may take that it is T 50% decomposition. T50, which is equal to 2.303 by K log here 100 by 100 minus 50. Now we may take 2.303 by K. It is log 100 by 50. So 100 by 50 is nothing but 2. So we are getting this one. Now we are taking that is T 99.9% decomposition. So T 99.9% decomposition is nothing but 2.303 by K. It is log 100 by 100 minus 99.9%. Now what is that? It is 2.303 by K. It is log 100 divided by it is 0.1. Now here it is nothing but 10 power 2 and it is nothing but 10 power minus 1. So here 2.303 by K, it is log 10 power 3. It is equal to 2.303 by K and 3 log 10 base 10, and this is nothing but 1. So it is T 99.9% completion. Now we are taking T 99.9% divided by T 50% is nothing but you may cancel out this one 2.303 K and divided by 2.303 by K. So what will happen here? It is nothing but 3 and divided by it is log 2. So it is 3 log 2 value. So log 2 is nothing but 0.3010. So it is 0.3010. So it is approximately 10. So here T 99.9% which is equal to 10 T50. So we may prove that here T 99.9% is equal to 10 T50. Students, in this session we are taking integrated rate law for first order reaction and zero order reaction, and also pseudo order reaction and half-life periods of first and zero order reaction. Thank you.